Okay, good morning everyone. We are continuing a review for log and exponential functions. Hopefully everyone had a wonderful break. We will be continuing with 2 more lessons on this, doing a calculator section there, and then we'll have a quiz coming up next week. We will be having I'm going to call this a problem set to work on. Okay, good morning, everyone. Hopefully everyone had a wonderful break. We are still continuing with 2 more lessons on Unit 5 with log and exponential functions. So today is going to be a review day. You will be completing a problem set 2 on Unit 5, and we'll be having a quiz on this stuff, plus doing some calculator things next week. But we'll talk about that more next week. All right, so let's get started. What is the meaning behind base c? So hopefully you remember that it's the inverse of the ln natural log function that involves exponential growth and decay. So here we're starting off with this one here, solving for x. Natural log of 6x squared equals 10. Remembering back before break about how we change this to exponential form. So we have an imaginary base e. We have the power, which is 10, to equal the answer, which is 6x squared. We're doing this so that we can get x squared by itself. So I'm going to divide 6 over. Then I have x squared is equaling e to the 10th over 6. I need to get rid of that x squared, so I'm going to square root both sides. Go ahead in your calculator and try that. And you should get an answer of 60.59. Next question, looking at this, our poke equation here, determining the starting amount, percentage of growth/decay, and how often that percentage is growing. So the starting amount, what's the starting amount here? It is 400. Our decay is decaying by 25% every 12 months. So remembering that 0.75, we need to subtract it from 100, so it's decaying by 25%, and there's that 12 there every 12 months. How do we convert this to poked form? So we need to first figure out how to get our half-life, and then from that half-life to get the constant decay. So to find k, we are going to take what's given, not worrying about the starting amount, to make it equal 0.5. This is going to help us to get our half-life. So let's change this to log form here. So I have log base is 0.75. 0.5 is the answer there. And here's the power on the outside. Now I could take that, and I could change it to change of base form. Hopefully you remember that one, the change of base form, which is doing change of base, taking log of 0.5 divided by log of 0.75 to equal t over 12. So I'm going to take the 12 and multiply it over to the other side. So I'm going to, in my calculator, do 12 times log 5.5 divided by log 0.75. Go ahead and do that. And when I put in the calculator, I get 28.91 months. That is my half-life. Now I need to go ahead and take this half-life, and hopefully you looked up the formula for k. K is doing the natural log of 0.5 divided by the half-life. So I'm going to take natural log 0.5, go ahead and divide it by the 28.91, and we get it to be negative 0.02398, keeps going on. So this is my k, my constant for my poke equation. So what is my poke equation now? So let's go back up to the beginning. My poke equation is going to be 400. starting amount. Now we have our E, our poked, with our constant, negative 0.02398t. So there is my poked equation. So what I want you to do on this next one is you go ahead and try it yourself. See if you can figure out what is the half-life. Then from there, plug it in to get the K. Pause the video, come back to see if you got it. Okay, so hopefully you figured out that your half-life was 5.43 months. And then when I plugged it in to get the constant, the K, I did natural log of 0.5 over that, and I got it to be negative 0.12765. Here is my poked equation. All right, now we're going to determine the half-life depending on what they ask us in the question. So let's look at A. A is asking us to determine the half-life of an amount with a decay constant of negative 0.054. Well, we all know how to do that one. We're doing the natural log of 0.5 over the constant, and that's going to give me my half-life. So do that in the calculator. You get 12.84. Number 2. Here, they're telling us to figure out the half-life from something that's saying it's dropping from 40 to 33 after 5 years. So let's see if we can figure out what that K is from what they give us. So to do that, we need to take our natural log of the 33 over the 40, divided by the 5, and that's going to give us our constant. So put that in the calculator, and I get it to be negative 0.0385. That is my K. Now I can use that K to get the half-life. So natural log of 0.5 over that K. In the calculator, I get it to be 19.95 is my half-life for years. All right, for the last one there, for 3, an amount drops 30% annually. Well, that means that it actually was going down by 70%. So I'm doing natural log of 0.5 over the natural log of 0.70 or 0.7. In the calculator, I get the half-life to be 1.95 years. So it decays by 30%, which means 70% is remaining. Okay, here in this question, a substance has a half-life of 55 years. By what percentage does the substance decay annually? So again, let's figure out what our K is there. So we're doing our natural log of 0.5 over the half-life. In the calculator, this is what you should get as my K. Now I'm going to take my natural log base E of that K, negative 0.0126. So if you put this in the calculator, I get this decimal. It keeps going on. So that means by what percent does it decay annually? Well, I'm going to do 1 minus that. And I get it to be about 0.0125. I'm going to change it to the decimal. So 1.25% annually, the substance is decaying. Okay, on this slide here, evaluate. We're going back to logs now. How do I evaluate these logs? Well, you could do the change of base formula here, change of base, which is the easiest in the calculator. So I'm going to do log of 1296 divided by log 6. Here I'm going to do log of 1 over 125 over log 5. And the last one, since it doesn't have a base, it's base 10, log 10,000 over log 10. So do those in the calculator, and these are the answers you should get. All right, now you should go back in your notes to the log properties about expanding and condensing logs. So here we want to expand this logarithm. So it says ln x divided by, and then underneath is x squared plus 8 times x cubed plus 5. So here we have division going on with multiplication. So what does division become in logs? When we expand, it becomes subtraction. So I'm going to do natural log of x minus natural log of this whole thing. Then I'm going to expand my multiplication here, which becomes addition. So this comes down. Now I'm taking my x squared plus 8, and I'm adding it to natural log x cubed plus 5. And that's all that we can condense it to. All right, once you've gone through this whole video and wrote this up in your notes and tried the problems, pausing and starting again, you could pick up the problem set now from the teacher. The key is in Google Classroom to check your work. Some of them you're not going to be able to do because we will be doing another lesson next class this week.